It depends on whether we have room or not. Okay, so that's just the start point for me to record. But if you look at to this, what is instruction right over here, so that's just really the timing we have to be careful. So there is no extension for none of these things. Okay, so it says Friday midnight is the time that you submit your work, so means you scan and submit, but the test itself is just really available right at 4 p.m. on Thursday, and then it will be closed right at 4 p.m. on Friday. So you have a total of 24 hours to find just 180 minutes. Okay, so they have 180 minutes must be back to back, but you have 24 hours to open that. So because that was just really one of the concern for most of the students, especially if they have kids at home, they don't have quiet area to do the test. They don't have any nice time. So if it was just really class time, they were struggling to do the test or to be quiet during the test. So that's why I just said it doesn't matter. You can do it in the afternoon, after 4 p.m. You can do in the evening. You can do midnight, and then as long as you are happy about the time, and then the day after is Friday morning. So however you can just make your kids quiet to do your job for 180 minutes, so you're fine to start the test. And then as you see it's here giving to the two submission, that's just really natural to think if you are all in a group of studying and then you have done many work together, so naturally you ask questions from each other, which is fine. So you can ask questions from each other, but that's just really mentioning, I know that you will ask questions from your group or your classmates. This is just perfect, but don't copy from each other, because I'm, as of now, I've received many papers from you, quizzes, worksheets, and handwriting. I know what's your handwriting, I know what's your wording, I know what's just really your format of writing always. Okay, so this is just really number two, to remind you, write your own your word. Okay, so you can't copy from your friends or somebody else because they are helping you. So you must at the end come back and do your steps by yourself. Copy paste does not make sense. Okay, so as of now I know your work and the format of your writing, so I can guess who is writing or not. And then so for the number 4, as it says, is there are a total of 17 problems. And then for the paperwork, it is just really 4 p.m. to the, what is it, the afternoon is 12, huh? So you have 8 more hours to submit your paperwork or the work that you have done to get the last answer. And I could just put this one to be right on WebAssign, but if you don't have iPad or something to write on that, it's just really tough for students. That's why I requested to bring it here and just upload it on my Titanium, because I could just say on WebAssign, set the setting to be just short answer question, then you could write it on that. But if you don't have pen or something like iPad thing, it's just really hard to do. That's why I requested to bring your work over here. And then so as you see, it's 50-50. So your solutions is 50% of your job, your answers like there is 50% of your job. And so it has to be both. It doesn't work one to the other. So you have to, there is no extension for none of them. I think it's really 24 hours plus 8, so it's just enough time to do everything. So I don't think there's any excuse about I don't have Wi-Fi. So don't put it in for last minute. I don't have a scanner, because all of us has at least just a phone on hand. And then when we have a phone on hand, so iPhones has just built-in scanner, Android has just free scanner, so you can just upload it. I don't think there's any excuse, because we have done many of them as of now, that uploading thing. And then just write the steps as much as you can, as you're supposed to do in the test. And just as I said, help me to give you partial credits if you miss the entire problem. This is about it. Any question here?
I have a couple of questions.
Please.
Well, first one, though, the exam is kind of long, so I was wondering if there is gonna be, is it like when we started, do we need to take the whole, is it gonna take up our whole 180 minutes, or is there room for us to like take a little break?
I don't think there is any room to get the break. No, never. So there is no room to get the break. But you see the actual problems by the computer and by the estimations, by just the average that, you know, all of those data that we have from the computer, supposed to finish in about 90 minutes, less than 90 minutes. So for all of those extra things that you said right now, like taking just restroom or something like that, that I made it double time. So
Okay.
it doesn't mean you need really double time. So
Okay.
you can finish it in, that's just what the computer says, okay?
Okay.
Based on the data of all the students that are just doing the web assignment problems, it says 90 minutes test. So I made it double for those things, but just really manage your time. That's all on you. You just see all the problems, which one takes more time, which one takes less time. So which one I want to do first. This is from this section I do first. This is from this chapter I do first. So it's just really showing your work, which takes more time. Okay, so that's just managing your time.
Okay, and then you said that you might give small hints if you're stuck on a question. Do we email you about those?
I don't think you need such a this thing. Usually it's not really any case, but yes, if you have had any case that you think you just want to because you have enough resources, right? So on your hand you do have enough resources, so I don't think you need any, but if you have had, yes, that's just the option.
Okay, thank you.
Any other question?
I had a question about the extra credit for the homework that we've done so far. What sections particularly you were looking for? And because I took pictures of all of the homework from 11.2 until 11.8, and I uploaded that to the link that you had provided on Titanium. But I didn't know if you needed to include 11.1, because I thought that was taken into account for the last one.
No. Okay, so first of all, there was many students that last time they didn't just put the 11.1 and 2 last time, so that was just one of the issue. So because it was just I believe the due date was after the test, so it was really the same day of the test, so that's why they haven't had it. So that's just the reason that I said the entire chapter 11. If you don't include, I can just really remember who was included or not, but I'm fine with that. And then the chapter obviously what is 12 is not included in this part. And then that's a good question, because I just want to remind you, if you don't have a scanner like just to do all these 100 pages that you have done your work, I don't expect you all sit down and just scan all the pages, okay? So there are the alternative options. So means if you have had paper works and then you have so many pages for your homework or extra credit, and you don't want to sit down and just scan every single pages, so you need to make me just have the individual meeting and like now, and then just give me your camera and start to show your pages through the camera. That works too, okay? So that's just really better for someone who is the online link is better for someone who is just making the note through the iPad. So it has something on the computer they already saved, so that saved a lot of time, so they can just use it right there. But if you have so if you have what is it, papers, and then you have so many of them and then you don't want to scan all of them, I suggest you to scan, because the scan of your work is keeping them forever. But if you don't want to do it and you see it's a lot of work for you or a lot of time, so just in any of these individual, like right now after the meeting, you can just show me the pages through the webcam and then we are fine.
I just as a note, I took all pictures with my phone of all the pages, and then the school gives us access to the Adobe software. Specifically, it's called I think Adobe DC, and that allows you to make a PDF of all of those pictures. It combines them into one big PDF. I had to combine mine into two separate PDFs because the upload has a limit of 100 megabytes or something like that. So I had to split it into two separate PDFs, but it's all the chapter 11 through 1 through 5 is one PDF. And then my pictures of 6 through 8 is also a separate PDF. but the Adobe software allows you to create a PDF of all your pictures using.
Where can you find them? Is just really CSUF software student access, something like that?
Yeah, it's the if you like Google CSUF IT, their or CSUF software, like they'll have a student link software that you can click on, and it'll have something for like Adobe Creative Cloud, and one of those options is to download the Adobe DC Creator. And if I can look up a link and post it in the chat for anybody who's looking.
Okay, perfect. Thank you. Okay. I don't have mine too, so I don't mind to have it. Okay. Any other question? So if I go back to the titanium page, which one is yours? That was the titanium page. And then, as I mentioned in the email that you have received, so everything is in the same place. Yeah, Stephen posted the link if you need that Adobe. Yeah, what else do we have? So the chapter we review is there, the double integration of, okay. So remember, I have extended all your homework, and then I just try to stretch everything throughout the semester, as we are just having some holidays here. And then the next week is just our spring break, so we won't have anything due to the next week, but then is when we come back, we have just something to do for the polar. I will use the time of Thursday class to teach, okay? So if you have any question, I'll answer it right now, but the class time is just for teaching as usual. If you have any question about the test, okay, so exit ticket number 9, let me see whether we have anything nice over there. Okay. The most significant ticks that you
Yeah, there should be good stuff since I wasn't there to complain about anything. So.
Oh, okay. So you are the complaint guy, huh? But you can always just, I mean, the complaint last time was just really all about the due date because I forgot to change them. So it was just really easily email me, okay, can you change this the due date? That was just it. I mean, it's not, I forgot it. It was a lot of thing to do.
We could have just emailed you. I would have.
Yeah, that was it. That was it. Yeah. I email. Yeah. So even when you did not email me, I just extend everything, right? So I extended everything because I was just really gradually changing everything. That was just me to have just all changes in all my classes. So it takes time. So it was just really basically change the due date that I forgot to do. That's it.
I had to edit that complaint so much because I was so upset. It was actually longer than what I finally posted. So, wow, okay. All right, so, I'll remember this next time.
Yeah, that was easy. Yeah, okay. So I tried to switch the order of integration, kind of hard to understand. I need to practice. Okay, so it seems the questions are all about chapter 15. A civil engineer, double integration help to the build and design basis. I'm studying the topic easily. So this is just really change the order of integration. Yeah. I'm still unsure that how to solve the visualize the triple integral because it's just really hard to imagine. Looks like an independent need to practice this type. I'm still unclear to triple integration to, triple integration we haven't started yet because it's hard to visualize. And then some question asked to the volume boundary, why I need to draw a graph to double integrate to find the volume. So anyway, for all of this thing, is just from chapter 15. So yeah, we have tried many problems all through the semester, and I just strongly recommend, please don't skip any graphing from the beginning of semester. And that's the time I need it, right? So that's the time I need all of those graphing thing that we have studied in first class, and then again 10.7, and again in chapter 11.1, so and then so on. For every single problem from the first day of the class, I have had the graph, nice graph with the details and with the just really however I made it, right? So just making the level curves. So it's all the place that I needed from now so on. So if you started right now, that would be really great, because you will need it for entire chapter 12 to see the graph and then to visualize it, and that's just really practicing and practicing. And then in chapter 13, exactly the same thing. Chapter 13 is following of the chapter 12, which is just some kind of double integration and triple integration, and it's impossible to do without the graphing. It is impossible, okay? Because if I don't see the graph, how do I guess is it type 1 or type 2? Is it X first or is Y first? So that's the main thing, right? So without the graph is impossible. So again, go back to your first class and then 10.7, and then you have in your, what is it, just 11.1 to graph it. And for order of integration, that's just really a good question. I will just try some order of integration when we have a test on that, because changing order of integration is really some technique to solve for impossible integrals. So for integrals that is impossible to do, change the order of integration is just solve the problem. So as we tried it in the lecture note, and you have it one in your group work. So this is a really great question. But since the entire questions was on chapter 12, what the test is on chapter 11, I'm going to move on to the questions about the test first, okay? So let's just move on to the, where is your class? Your class is, Nura, do you hear my son? He doesn't stop to play the piano.
I heard. I was gonna say something.
Yeah.
But it's really cute. Yeah.
Yeah,
He's good.
he's just little. He's just practicing. But whenever he needs to get extra time for Xbox, he needs to practice a little bit.
Oh,
So
that's a good way.
that's his try. That is try to get at least 10 minutes more to play Xbox, because during the weekday they don't have Xbox to play.
That's all. I should have my students, because they don't practice. I
Yeah.
need to tell the
Yeah.
parents to do that.
Yeah, that works really great, because they do everything for Xbox. With more time for Xbox. Okay.
Good one. Good one.
So this is a review session. Okay. Now give me your questions. What was the question? Why you see different page? Why you don't see my screen? What do you see? Right?
Did you? We see titanium or the exit ticket number 9.
So usually it should show my screen, right? So I have opened my OneNote. Why it doesn't show the?
You need to choose which screen that you share, because it can only do one application at a time.
Yeah.
How do I choose? So it's easier
If you
for
hit
me.
share,
I will
share
stop.
screen,
So now you can see.
and then one will say share the screen, other ones will say share whiteboard or whatever other applications you have open.
So I stopped there. So then I have to say share screen. I think it was just share screen. I don't know what was it. Okay. So however, so now we are here. Okay. Do I have anything on chat? Is it for me or is it just for you? No, it's nothing for me. It's you for you. Okay. Okay. So this is me. Any question to do here?
Yeah. Let's see. Can you go over? Let me see with my. I'd like to go over number 1 from our test review, or at least a problem like that for graphing the like sketching domains and then sketching the contour plot for and the level clerk curves and stuff. I want to get those things straight because I get confused on how to put those ones down. And
so you know what, I need to know, because when I'm explaining something, it's just really on my side, right? So I need to know which step exactly is the place that you have problem, because you see, what do we call a level curve? So level curves is just when you have a function of 2 variables, so you start to get this to be a constant. So you can just call whatever constant you have, and then just really any number in real. So then what you get is a function of, so then the result is going to be a function of x and y, and which we learned how to graph. So how to graph all this is going to be in algebra classes. So that's just really the steps, okay? So to make the level curves, you set the output name to be a constant number, and however is given in the problem, or you start it from just 0, and then you just say, okay, so whatever is the result right over here is going to be what we have learned in previous algebra classes. So for example, it could be a line, it could be a parabola, it could be a hyperbola, and then since now you have access to your internet, you can just say which one is which one. It could be a circle, it could be ellipse, right?
Yeah.
And
Like
so
the problem that we had on our equation or whatever, I think it was the ln of x squared y as far as our graph, for example, and it's a sketch the domain of f, and then it was like looking for the level curves when z is equal to 0 and z is equal to, I think, the ln of 2 was the
what was the function? I don't know.
parameter.
Do you have it, or you don't have the function? Do you have the function? I'm looking for the sample.
Yeah, did you not see the annotation I wrote? I don't know if that's something that's working. The function was the
natural log of x squared times y.
Yeah.
What was it? Z equals natural log of
x squared times y.
X squared. Yeah, x squared times y.
Times y.
Yeah.
Okay. This is just the function, and then some values for here. So let's say, as I said, k is going to be a constant of 0. So that means 0 equals natural log of x squared y. So can natural log to be 0 for which value?
Natural log of 1 is 0?
Natural log of 1 is 0?
Yes.
Yeah? Okay. So this means you have x squared y equals 1. So this is just really what I said about the function of xy that we have learned in algebra, how to solve it. Okay, so this is just the list of the function that we have learned how to solve it. And it seems this is, if I want to just really see which type of this list is, you need to always solve it for y, right? So this is just really what we have learned in algebra classes. I don't know what is x squared y equals 1, but I know if I write it like this way, if I solve it as a function of x, if you solve it for y, then you can just see what's the graph. So that's just really what thing that I need to remember. Everything in calculus 1 and algebra classes was, oopsie, sorry, that was this way. In algebra and calculus classes was just y as a function of xy. So I need to solve it for y. So this is y equals 1x squared. And then if I said k equals natural log of 2, it's really natural log of 2 equals natural log of x squared y. So then I can just do anything when y is inside the natural log. So then in order to get rid of that, I have to e both sides. So then that gives me 2 here, and that gives me x squared y here. And same story. I have learned in algebra calculus 1 classes, y must be as a function of xy. So then I need to solve for y. So divide both sides by x squared to solve for y. So that gives you an next one, which is a little bit wider. And that gives you basically the pattern. It seems that's a pattern. If there was any other number, so the pattern must be like that.
Okay, so you're taking the original part here where 0 and the ln of 2, you're taking that just directly from our original parameters that were already given. Is that why you're setting those equal to your function?
Mm-hmm.
Like you're not just picking random things, you're just
I could if
picking
yeah, if it was not given in the problem, I had to. Right? If it was not given in the problem, I have to select by myself, but that's it's given, so I'm using that values.
So okay. So you're kind of seeing what the inside of your parameters and how that equals to 0, and then finding what is the inside, or how does the inside equal to those parameters, and then what does, okay. I think I understand.
It's similar to this, right? So it's not always natural log of something, right? So it could be different function, but it's just somehow take out somehow, where is it? Take out this y, and then have a function of y that you have learned somehow here how to graph it.
That I can graph. Yeah. Okay. That makes sense.
Great. Any question? Any other question?
I know we had a question for problem number 2. Problem 2, letter A, talked about it was a limit of XYZ. I think it was the limit of X, Y, and Z. Yeah, as the limit of XYZ goes to 0, you had X times Y divided by the square root of X squared plus Y squared plus Z squared. And we were looking to find the different paths to write out our parameterization for each. And I was getting confused on the, I think no matter what I do, my equation always ends up 0.
You know why? I don't.
And we had a 0. We ended up getting like a 0/0 as an indeterminate form. But
oh, it is supposed to be 0. I think what you're missing is x is equal to r cosine theta and y is equal to r sine theta, and so that's r squared cosine theta times sine theta, and the denominator is the square root of r squared. Take the square root of that, the r's cancel out, and you have an r in the numerator. And so as the limit of r's, or the limit as r approaches 0, you plug that in, the whole thing goes to 0. So your limit exists at 0, or it is 0. I think that's just something that we forgot to do. So yeah, it's basically.
You know what my problem is? I don't see the problem. I have to erase extra files because I can't find the list of problems that you're talking about. But Brandon
on the board, I think.
Brandon, but the thing is, you have to erase it, and I cannot erase it. Yeah, I know you can write it, but you have to erase it. When I'm moving, it's just like glass; it stays there. If you write that, it was just something that we tested like last time. But that's fine. On the other computer, I just log in, and I can just now get that one. I don't know where did I put the file. Okay, yeah. That was just something which is a little bit different. Okay, so
I did something different and I got the same answer.
So what did you get? What did you do?
I plugged in z equals 0 and y equals mx.
Let me just write it over here. X, y, that was just x squared plus y squared plus z squared. And then you plug in what? Y equals mx.
0.
Z equals 0.
Yes.
Okay. So that gives you all in function in terms of the x, right? So you have to plug in xy is approaching to the origin, right? So you have x, then you have mx, then you have x squared, then you have mx squared, x squared, and then you have 0.
Yep.
So that
And
gives
as
you
x
one
equals to 0.
X left on top, huh? You have x squared on top, and then you have one x out, and then you have one ms squared by if the x is positive, because we don't know whether if x positive, but I can just say x is like this, and then this by one of these x cancel out, one x left.
Yeah.
Then that gives you 0.
Yes.
Yeah.
Okay. And does the limit exist or no?
It does exist at 0.
Okay, so it's 0, right?
Mm-hmm.
Yeah, if you do the R substitution, yeah. If you did this one, I think what we're doing here is like checking if it doesn't exist. But you get 0 either way if you keep testing different paths.
Okay, so if you keep testing in different paths, it doesn't show the limit. So this is just showing one path. Okay, so you can say by this or 100 of these that you got 0, the limit equals 0, because as we know, there are something that we haven't tested. The only way that you can trust your calculation and say the limit exists was just really using those R method, or just whatever it is in 3-dimensional sphere, in 2-dimensional circle paths to approach, right? So otherwise you can't say the limit exists. So if you try 100 many of the paths and you get 0, it doesn't mean the limit exists unless you use that R method. Okay, does it make sense?
Okay.
What's the R method?
So it's like R cosine, or R is equal to X cosine theta.
Or the other way around. X equals
R.
R cosine theta.
Yeah. Oh, yeah. X equals R cosine theta, and Y is equal to R sine theta.
Yeah. And that would replace your numerator.
And then Z would just be R squared or R, right? Oh,
Well,
no.
your denominator is all
Just-
R squared.
Yeah. So it would just leave
So it's
Z.
the square root of R squared.
Yeah.
Okay, so this is a little bit different because we go in 3-dimensional, and that's what we will learn in next class. So the formulas, if you look into the solution, have you checked the solutions? Have you checked the solutions?
Yeah.
This thing in the coming section is going to be, I mean, it's fine to go by the entire thing is going to be R squared, but in coming section, I'm going to call this one to be a different letter, and that is just really rho. If it is a X, it's just rho sine phi. And then that's a rho cosine phi. Okay, so that's just really different letter. When you have a circle, this is just going to call R, but when you have a what is a sphere, this is going to be rho. Okay, so that's just a different name, because we do have what we call polar system, and we've learned it. And just to make it different, this call is called rho, and I mean this rho, and then that is just the new coordinate system, which we call it the spherical coordinate. So if you see that that problem right over here, this is just introduction of our chapter 11 to chapter 12. Okay, so then you don't have to know those formulas, but as long as you just accept this whole thing is going to be R squared, not only this part, which is that thing. Just to remind you, this is not really the R square or the radius of the sphere. It's just really the whole thing, x squared plus y squared plus z squared, which is your rho square or R square, however you want to call it. Okay, so that's just really main thing. And then in that case, you have how many? One row left on top, right?
Yeah.
Yeah.
these rows cancel out. Oh, sorry, that's a square root.
That's
So
square
one
root,
of them cancel out, one of them left. So that's why it's just 0. It's just 0. Yeah. Okay. Any question? Does it make sense?
Yeah, that makes more sense.
Any other question here? You know, this is not official class, right? So it's just really asking questions. If you don't have questions, you don't have to stay here. And I said it's just really 10:30 to 11:30. You have about 10 minutes left.
I have a question about the questions, your review questions.
Do you know what happened to my board? Who wrote on my board? Can you?
Oh, sorry.
Okay. If you can, it stays there. Yeah, thank you. What was Nora?
Do you see the questions, or do you want me to read that to you?
No. What was the question? I didn't. Sorry, I didn't follow you.
It's number 14, just like not the whole thing, but just one part of number 14.
What's the 14? So consider this is just your surface, and then find the equation of the tangent plane, and then get the derivative in terms of the x. Okay.
Right, but like anything we have done when we were getting the tangent plane, we would write it in terms of like z or w. But here in your solution, you put it equal to 0. That's my only question on that one.
So if you remember, there were just really 2 forms of writing the tangent plane equation, right? So your tangent plane equation, if you want to go by the 11 point, I think it was 4, and then it's just 5. You could have z minus z naught, then partial derivative in terms of x minus x naught, and then partial derivative in terms of y minus y naught. Okay, so then you can extend it to the 3-dimensional, and then you just have to just say partial derivative x minus x naught. Okay, that's just really in a case that you have explicit what is function in terms of so for example, for this case, your z must be explicitly written as a function of xy, right? Then you can just do this step. For this one, your w must be explicitly written in terms of xyz, so then you can do in this way. Okay, but if you're having the capital function of xyz then equals 0, then you are using the other section, or the gradient vector one, which the gradient vector is going to be a normal vector, and then that's a place that we called it to be capital F instead of all little f that I have over here. And then we just set everything to the 0, and then start to do the gradient vector. So if you want to use the gradient vector version, which that gives you the partial derivative in terms of x and y and z to be your components, remember everything must be on the left side, and right side must be equal 0. Then this is your a, this is your b, this is your c.
So we can do it the other way?
I don't think so, because there is no way to solve for z. Okay, so can you solve the entire equation of the z? Because z is inside the sine xy, right? So let me write the equation over here. I see here, so that's just really implicitly as a function of x, y, which there's no way to get that equation explicitly. So then no, you can't. So you have to put it one way, set it equals 0, and use the gradient vector. Steven, do you know how to just really bring that keyboard here on the toolbar? Because it was there, now I just erased it, and then I don't know how to bring it. We can ask later. Okay.
The keyboard to type the.
Yeah, so it was on the bottom toolbar, but now it's not there anymore.
Oh, do you have a keyboard attached to your Surface?
I do. Should I?
Okay.
If I just make it.
It depends on if it's in laptop mode or tablet mode. So if you have the keyboard like swung behind the screen, then it should register it as you need a virtual keyboard. Rather, if you detach it from the keyboard, then it'll come back up.
You think it's here? No, it's not here. I want to be here.
Yeah, like I have mine, but it's switched. Like I have my keyboard flipped underneath my screen, and
I know.
yeah,
I don't have such that keyboard. I didn't buy that keyboard. I just
okay.
have the extra wireless one.
Oh, you just have an extra wireless one. Well, yeah, that's why it's connecting your keyboard wirelessly, and so it doesn't think that you need to have a virtual keyboard at the moment. So that's why it's not showing up.
Okay, thank you. Any other question here, guys?
So when they ask for the tangent plane equation, we're pretty much is always going to have this equal to 0. That's what we're finding with a normal vector, really.
That's what we prefer. I mean, I think that's just really better, huh? Better than solving for W and worry about this thing has
variable
to be explicitly, right? So that's just better than thinking about that way. We just say, set everything equals 0, start to put the gradient vector as your normal vector.
And we would still have a z naught. Like, say we said z was this large thing, we would still have z naught.
Yeah, we do. So that's just really partial derivative with respect to x minus x naught, partial derivative with respect to y. That's why in the problem it's giving you what is the z naught, right? Because you can't plug in to find it.
Okay.
Any other question anywhere? It looks you practice. That's great. Thank you, guys. It looks you practice from your review problems. It's not going to be something that more than what you have practiced in your homework or you have seen it in review. So it's just very equally selected problem. I think is each section 2 problems. So it's just equally selected from the problems that was just really similar to what we have practiced. And it's time, I will say, consuming is same as your homework because of the derivative, but the good thing is you do have access to everything, huh? So as long as you know the process and the concept behind of each question, you can attack quickly to see, okay, so this is what I need. That's the tangent plane equation. This is just differential, or this is limit. Okay, so that's just what the skill you need for this type of online homework. So which problem is for which section, and then you can attack because you have enough resources on your hand.
And do you think reviewing our group works from these sections or whatever would also be useful for study?
I strongly recommend always to study the group works. So this is just really good practicing for us. I'm happy about we have this chance because in calculus classes we usually don't have any chance to make take-home tests for so many reasons, because the questions are really standard questions. They're always coming from somewhere, from some book, and then it was available, the solutions are available. But this is really first time we are practicing the take-home test for the calculus class, and is just not really writing formulas. So there is no credit to write the formulas. There is no credit to copy from your lecture note, because that's just what you have on your hand, or copy from somewhere. It's just really the skill of how you process a problem. I think you will be happy at the end. Any other question?
I have a question on number 7.
That is very similar to the example that we have had in the class, right? So you suppose, since this is a disk, you're supposed to go by 3 steps, right? So your function is just x squared plus y squared minus y, and the disk has the radius of 2, right? So then the 3 steps is just for here. Step number 1 is what? Step number 1 is find the critical points inside the region, right? And then step number 2 is find your critical points over the boundary. And then since your boundary is a circle, does the problem ask us to do with the
This is Lagrange.
Lagrange? Yeah, because the boundary is just I mean, your g of x y is just really x squared plus y squared equals 4, right?
Mm-hmm.
And then step number 3, list all numbers, list all points.
So we could say g of x is equal to x squared y plus y squared is equal to 4, even though the parameters is saying greater than or sorry, less than or equal to. We can set it equal to 4.
Because that's a boundary. For less
Okay.
than equals, you take care of them when you just set the partial derivatives equal 0, right?
Oh, right. Okay.
And then this is a boundary, so it's just really the thing. Okay, so should I do more, Sylvia?
Yes.
Should I continue? So the partial derivative with respect to the x is 2x partial derivative. This is for step number 1. So then partial derivative with respect to y is 2y minus 1. This is equals 0. This is equals 0. That gives you x equals 0, y equals 1/2. So it's just 0 and 1/2. And then all is important to know whether this is going to be inside the region, huh? So this is just somewhere inside, right? Because it's just really half. So, so if it is inside, I'm fine. I need the value. And whatever is the value is going to be 0 squared plus half squared minus half. And that gives you minus 1/4. Am I right? Then step number 2, I have to take care of f and g, because that's just it's just suggests us, because it's easier to do with the Lagrange. So then you have to set partial derivative with respect to x, lambda times partial derivative with respect to s, partial derivative with respect to y, partial derivative with respect to y. So that gives you partial derivative of x, set it equals lambda partial derivative of x, partial derivative of the y, lambda. I know where is the problem. That's why I'm just doing really quickly, because I know where is just the issue usually. This, that tells me equation number 1, equation number 2, equation number 3. So number 3 is my x squared plus y squared equals 4, which we have to use it last. So that tells us we can just say factor the 2x, 1 minus lambda equals 0. So that gives me 2 cases. Case number 1 is x equals 0. Case number 2 is lambda equals 1. And then lambda equals 1 is nonsense in equation 2. If you plug in equation 2, lambda equals 1 is nonsense. So then I have x equals 0. If I plug in x equals 0 right over here, that gives me plus y squared equals 4. Y is plus minus 2. So that is 2 points that I need the values. This is number 1. For number 2, I just keep going to have, that's the ugly part. This is the ugly part. That's just the issue most likely. So if you just have, what is it? 2y and then minus 2y lambda equals 1. So if I factor 2y, then I have 1 minus lambda equals 1, okay? And seems I can't get any solution from here, okay? However I do, I have tried it in solutions, and then it just really seems I have no way to get any solutions here. So for example, that tells me if lambda is not 1, sorry, I put the lambda because I need more room for this one. So I put the lambda, if lambda is not 1, so then I can divide both sides by 1 minus lambda. That gives me y is, what is it, 2, 1 minus lambda. And then if lambda is 1, we just said it doesn't work. So that's just really not the case. Since it was just really not 1, it could just really divide by that. And that's just really the problem, because if I say x squared plus y squared equals 4, I have y, and then I have to have x. So then it goes nowhere. So to plug in, if you have the y over here, and you plug in here, so still x is something, and then lambda is here. So then you have 2 variables, and that's not possible to get any solution from here. Okay. Okay, so that's why I don't get any solution there. So now, Sylvia, now tell me, where was the problem that you asked the question?
I was unsure whether or not I could, like, whether or not I should have done the first step. Once you finish step number 1, I'm like, oh, that makes sense. But I still had problems with this guy.
Mm-hmm. So you seen the solution by my handwriting. I've tried to do something, it goes nowhere. So then we stop there, right? So there's no way to get any solution or any other critical point over here. So I have done some details in the solution, and then I stopped. So that was just really 4 of them. To list it, there is the other one. Oh, sorry, 3 of them. And that was just a positive, and that's negative, huh? These are the value.
I think I had the same problem too, because we normally didn't put the critical points equal to 0. I mean, we usually didn't do the step 1 for the Lagrange problems.
So if you remember in your lecture, if you go back to the lecture one more time, and then look at to the similar problem that we have had there, I can bring it for you to just remind you. We do have this type of problem. Okay, so this is going to be on your course, and that's just Lagrange multiplier, which is 11.8. Okay, and then if I go, somebody wrote the limit. You see, I can't open. Just, I think, Sylvia, you need to erase that thing.
That's not me. I wrote in purple.
Blue. Who wrote it in blue? Okay.
I think I wrote it in blue, but it won't let me erase anything.
So it's somewhere else. Huh? That's fine. Why does it move? This is okay. Where is that problem that we have tried in the class? Oh, okay, so it's right here. Okay, so it's right here. So when you have done this problem in the class, so since it was just right over here, equality, okay, so it's just, where is my pen or something to write? So this is, so this is, yeah, somebody wrote it for me. So if you have equality over here, so that is what? This is just really over the boundary, and it's just obviously my Lagrange multiplier. Now I'm erasing. Now I can just move to the next problem. No. How do I get rid of that thing?
You need to switch back to the mouse function.
Yeah.
Mouse function, it's here, okay. So then if I go to the next problem, which is, oops, it's here. So then that was the disk, okay. So here, which is the disk, right? So here, which is the disk, You're faster than me. So that then, if you remember, I've done the step number 1 in set the derivatives equal 0, and then step number 2, it was just the whole process of Lagrange multiplier that we've done in previous problem. You just really go back to look at this problem. Lagrange multiplier method for the boundary, and that was just really g of x y is just your x squared plus y squared equals 1, and then it's not as good as the other one, huh? One note is really better. When I'm writing fast, you can't follow me. So this is the okay. So then for step number 3 we have listed, yes. So then remember, that was just really the big difference. So if you remember, most of the problems in Lagrange multiplier doesn't have this step because it wasn't the disk. Now it is a disk. Okay. Fine.
Think so.
Nura.
Yep. Yes. Thank you.
Any other question? Okay. Any other question? Okay, so if you need any other question or anything individually, and still remember, there should, all my questions were answered. Okay, okay. Yeah, so you need to email me to make individual Zoom. Okay, so if you think I think your group chat or whatever you have on your what is it, group work, voice thread, or however method you have learned, I think right now you can just, have you tried to do Zoom together? So those are really the best method to still continue to work together, to study together. But still, if you need my help, you can always request just individual meeting by Zoom and answer your questions. Okay, any question?